I'm David Gamm, and I'm Associate Professor of Pediatric Ophthalmology and Strabismus here at the University of Wisconsin. I also am the Director of the McPherson Eye Research Institute at the University of Wisconsin, and I'm an investigator for the Weizmann Stem Cell Research Program. Choroideremia is an inherited genetic form of blindness that affects the back of the eye, and it's one of a number of different types of genetic disorders that leads to blindness. So my laboratory strictly focuses on two of the three layers that are affected in choroideremia, and that's the retinal pigment epithelium and then the neural retina itself. The vascular layer, the blood supply, is an entirely different type of cell from the other cell types that are found in the retina. And just like almost any other field or occupation, you can't be a jack of all trades. So what we're able to do in vision science and through the Choroideremia Research Foundation is we find people who are experts in these areas. We don't have to be an expert in every single area. And in the case of our work with CRF, we've joined with Jerry Luddy, who is an expert in the blood supply that feeds the back of the eye. If the disease really is affecting the blood supply and the blood vessels that are in the back of the eye, then we should be including those cell types in the testing of therapeutics. For the most part, people don't do that. And so having a stem cell-based model system of choroideremia that has all the potential layers of different types of cells that could be affected is important, because we want something ultimately that will either protect all three layers or replace all three layers. For somebody who's completely lost vision, I do believe that stem cell therapy will be able to restore some vision. The extent to which that's going to occur is something I can't predict. So whether or not you're going to take somebody who's completely blind and allow them to see formed images, right? See motion, see whether the lights are on or the lights are off, if something or someone is moving across a room. That's a level I think that's achievable in the foreseeable future. If you're talking about, can I read the fine print in my newspaper, I think that's going to be, again, that's going to be the end goal, no doubt. I don't think anybody's going to stop or rest until that's achieved, but that's going to take time. You know, nothing gets done without funding, whether it be at the university level or if a company is involved in a project. Ultimately, something's got to pay for the reagents you bring in. I mean, you don't build a prototype computer or a prototype car unless somebody's providing the funds to do that. The different ways that we go about getting the funds necessary to do these studies are through federal grants, which is the kind of the traditional way that people do that. That has not nearly kept up to the pace of the improvements in the science. Just the funding isn't there. Foundations are really, really important. Most of the foundation grants that we receive and what we've been fortunate enough to receive from the Choroideremia Research Foundation have resulted in building research teams. That's really powerful these days, and it is becoming increasingly powerful.